problem says a rectangle has one corner in quadrant 1. So here's your rectangle, one corner in quadrant 1, right there. On the graph of that's that point right there. There's the graph. That curve is that equation right there. Okay, and another at the origin, and a third on the positive x or y on the positive x-axis. So if I were to move this down, that would be my rectangle.
Okay.
So this is basically, this rectangle can be anywhere along there as long as one of the coordinates is on the x-axis, one on the y-axis, and the other one on that line. Okay, so it says express area as a function of x. Well, if we think about what we're doing here, let me erase some of those triangles. If we think about what we're doing, we're taking this distance right here times that distance right there, but it's changing based upon this point right here. So how are these points related? Well, this is x, and this distance right here is y. It's that distance right there. And what is y? Well, y is equal to, how is y related to x? It's that equation right there. So that point right there is 4 times the square root of negative x minus 8 for whatever x is. In this case, it's 6. That's what x is, so you'd plug in 6. 6 minus 8 is negative 2. The negative of that would be positive 2, so it's 4 square roots of 2. 6 times 4 square roots of 2, because this is your x coordinate, that's your x, and that's your y when x equals 6. But if x equaled 6.5, it'd be different, because you'd plug in that different number. But that's the expression. So express the area as a function of x. They mean, right, area. We know that area equals x times y, but that's not a function of x. That's a function of x and y. So we need to rewrite y. And we know what y is. Y is that equation right there. So the area just equals x times 4 square root of negative x minus 8. That's what a equals.
Okay.
So that's the answer for that first part.
So this rectangle is drawn based off of slope of this, or?
Yeah, the rectangle is changing. The area changes depending on what x is. Okay. Depending on what x is, the area is going to be different. So if x was there, then y, I can't see that very well. If x was 7.5, for instance, then your rectangle would be that, and the area of that rectangle would be whatever 7.5 times 7.5 times whatever the y value is right here. And that y value right there is based upon this equation right here. Plug in 7.5 in for x, so it'd be positive 1/2, so the square root of 1/2, it'd be 4 times the square root of 1/2. And whatever that product is your area for that yellow rectangle.
Okay.
That's what it's saying. So now it's saying graph a of x and find the local maximum. What does this mean in the context of this problem? So now what they want us to do is graph this function right here, a of x. They want us to graph that. Now, in this class, they want you to graph it with your graphing calculator.
Yeah.
That's what this problem is. If you were in a different class, like a calculus class, they would actually want you to find the area a different way, because there's different tools by then. But for this particular instance, they want you just to take out your graphing calculator, to look at what that graph looks like on your graphing calculator,
Okay. Sure.
and find the maximum, find the local maximum. So find the point, if there's a point on that graph that is clearly the highest of all the other points for that given domain. Now, there's also a domain restriction here, right? We see here that x has to be between 0 and 8.
Yeah.
X can't be bigger than 8, and it can't be smaller than 0.
Okay.
In fact, it can't equal 0 or 8. X has to be between 0 and 8. It can't equal either one of those, because then there wouldn't be any room left for you to go up or down. it would be just a line, not a rectangle. So there's your domain restriction. Now, they didn't ask for the domain restriction, but that might be a different problem you might see would ask, what's the domain restriction for this graph? And that's what you would say. So in your graphing calculator, it looked a little bit like this right here. And when you use the trace function, or calculate the maximum function with your graphing calculator, you'll find that it's right about here, and it'll tell you that x equals 5.33 approximately. So now they're asking, find the local maximum. And by the way, the y value is 34.83. At that x value, 34.83 is the maximum. So the local maximum would actually be, they're talking about the maximum value. So the maximum value is 34. So A max is approximately 34.83. And this means, and I would even say at 5.33. And then what does this mean in the context of the problem? And this is where you would write something like, this means that the largest area, the rectangle with largest area occurs at when x equals 5.33. And that area is approximately 34.83.
Right.
So that's what you just found there is the maximum within that domain restriction from 0 to 8.
Okay.